Good morning, all of you. Let's wait for 1 or 2 minutes, then we'll continue. Good morning, all of you. Uh, Today, we'll be starting up with the new chapter. Actually, we had already started last time by learning the tool that is Veka tool we had discussed. So, we had started up with new chapter. As per your syllabus, what has been defined, it is the last chapter, but still we are left out with one more chapter about data warehousing, which we'll be discussing after the completion of this chapter. Maybe we'll be completing this chapter by tomorrow, or that is by next lecture. There is nothing new or nothing more in this chapter. It's very easy chapter what we can understand. It is somewhat mathematical and somewhat theoretical. Uh, if I discuss about this chapter, then the chapter name is prediction methods. Prediction method, if I discuss, then if I tell you very simple, prediction means we want to predict something from the existing data set. We want to define some continuous values, or we want to define some discrete values. In that case, we will be having the prediction methods. We need to predict something. Say, for example, I am having the data set, and from that, I want to predict that what will be the weather tomorrow. I'm predicting. I'm not saying that it is going to be the same, but I want to predict the weather tomorrow based on today's condition. If today is somewhat cloudy, then tomorrow is surely going to rain. Likewise, I want to predict. So at that time, we can go for prediction methods. Now, for predicting something, we should always have the data set, like what we did in classification. In case of classification, we were having the data set, and based on that, we were able to classify the data. But in case of prediction, the method of prediction requires the data set to predict something. So, what should be the prediction? As I given you an example of this weather forecasting. So, it is an example of prediction. Same way, if I am having an example of list of students who has given some entrance test, and based on that, I predict that this student will be placed into the company or not. So placement statistics I can find out. I can predict whether the student will be placed or not based on the statistics I am having. So the thing is, so the prediction takes place when we want to predict the value which is dependent on some other value. One parameter which we want to predict is dependent on the other parameter that we want to learn. So let's move further. So let me share my screen. So we'll be learning the prediction methods. Yes, there are many prediction methods available, but out of which we'll be learning only 3. We are supposed to learn only 3 which are highly used. So we'll be starting with regression. Now, what is regression? Actually, regression or prediction, I can say one and the same thing, because regression is a mathematical term and prediction is a data mining term. So regression. So regression analysis is a statistical process for estimating the relationship between dependent variables or criterion variables. I can say dependent or criterion. That means the placement is dependent on the score of the entrance exam. Placement of a student is dependent on the score of his aptitude exam. So regression is a statistical process for estimating the relationship between the dependent variables or criterion variables and one or more independent variables. See, the placement is dependent on aptitude exam. So aptitude exam is independent. It has no concern with placement. It is taken separately. But placement is surely dependent on entrance exam. Likewise. So the weather forecasting, what will be the weather tomorrow, that is prediction. So it is dependent on today's weather. So variables are dependent and independent. So always we will be predicting the dependent variable. See, always remember, we will be predicting always the dependent variable. There is no need of predicting independent variable. So always we will predict the dependent variables. So regression analysis explains the changes in criterion in relation to changes in select predictors. See, the thing is, what I have in this point, what I want to say is, based on what parameter my data changes, my dependent variable changes or criterion changes based on the independent variable. So what are those parameters? That is what is the analysis to be done using regression. Now, repeating my point again, regression is a method of prediction. Actually, regression is nothing but, as I told you, regression is a mathematical term which is used for prediction in data mining. So wherever I use regression, that means I am talking of prediction. So 3 major uses of regression analysis are determining the strength of predictor, forecasting an effect, and trend forecasting. See, these are the 3 things which I can predict using regression. The first is the strength of the predictors. Predictor means, I'll come to the definition. I'll come to the thing what I mean to say by the predictors. So strength of predictor, how accurate it is. Strength means how accurate the predictors are. Then forecasting an effect. Say, for example, if I define the predictor, based on that, I am forecasting my effect. That is, say, what will be the weather tomorrow. If I am forecasting it accurately, then it is fine. And trend forecasting. What is the trend? So now a trend, if I want to define the trend in case of news and media, there is the biggest trend going on is Sushant Singh Rajput. Second trend going on is India-China the dispute going on. So these are the trend forecasting. I can predict that if these are the parameters, then this may happen. This is what is getting predicted. So the three things I can do using regression. The first is predicting the strength predictor, determining the strength of predictor, forecasting the effect, and trend forecasting. Now there are various types of regression available, out of which we'll be discussing three. Over here there are seven types of regressions available: linear regression, logistic regression, polynomial regression, then stepwise regression, ridge regression, lasso regression, and elastic net regression. Out of which we'll be discussing linear regression, logistic regression, and we'll be also discussing polynomial regression. So these three regressions we'll be discussing. So starting up, actually the polynomial regression is one of form of linear regression, which I'll be discussing, don't worry. So if we move further in this case, then we'll be starting up with the first type of regression. And the first type of regression, that is what we are having, is linear regression. So linear regression is used for predictive analysis, very for sure. Then linear regression is a linear approach. See, linear, a line, a linear approach for modeling the relationship between the criterion or the scalar response and multiple predictors or explanatory variables. See, now the term changes. Now we are going on to the mathematical part. See, scalar response, that is relationship between the criterion or scalar response. Now this is what we are talking of: two things, dependent variables and independent variables, and the multiple predictors or explanatory variables. This scalar response is what we are talking of independent variables, and multiple predictors or explanatory variables we are talking of independent. Scalar, independent, confusing the terms. Scalar is independent and predictors are dependent on the scalar response. So linear regression focuses on conditional probability distribution of response given the values of the predictors. Sir, that is fine what you discussed, but we are always facing difficulty with probability. Now, probability is the term used over here, but there is no probable in this case. Probability means we are talking of what output we will be predicting, whether it is a probable output or not. So that is what we are discussing. We are not going to calculate the probability over here anywhere. And the most I could say the limitation or disadvantage of linear regression is there is a danger of overfitting. I'll show you the diagram at that time, you'll be more clear. There is a danger of overfitting. I think in maths you have studied the subject of computer-oriented numerical techniques or likewise, in which you studied various types of fits, straight fit, best fit, likewise. There was a concept of that particular part. It is similar to that one. Now the formula for linear regression is given as y equals to b1x plus b0. Can I say this is the equation of line? Y equals to mx plus c. This is linear regression is nothing but the representation of the data in form of single line. A straight line, I should say a linear line. Straight line means I am talking of a linear line. So whose equation is given as y equals to b1x plus b0. Now over here x is independent, whereas y is dependent on x. Again, y is not only dependent on x, it is dependent on these coefficients also, b1 as well as b0. So y is dependent on highly on these two parameters. X is fine, this data we will be having, but we need to compute this b1 and b0 to fit our data within this, so that we can predict whether if the data gives us the linear line, then we can predict. But now the question, the most important question comes into our picture. The most important question comes into the picture. Sir, based on the data set what we have, how can we say that which regression we need to apply? over here, as you said that in this case we are having linear regression. Yes, exactly. The first and foremost thing what you need to do is you need to plot your data set onto the graph. XY plotter. You need to plot your data set onto the graph. And based on that, you can decide which regression is to be applied. So the prerequisite is for linear regression comes out to be that simple linear regression is appropriate when following conditions are satisfied. As I told you, you need to plot the points, plot the existing data first. The dependent variable y has a linear relationship to the independent variable x. Now, how can I check this? Make sure that xy scatter plot is linear. That means when you plot the values for x and y onto the graph, you should get some linear graph. And for each value of independent variable x, the probability distribution of y has the same standard deviation, sigma. Standard deviation, it is a mathematical concept. I will not go into the detail of it. You should know the standard deviation. So when this condition is satisfied, the variability of residuals will be relatively constant across all values of x, because when the value of x changes, the value of y is going to change. So for each and every student, if the result of the test changes, then it is for sure that the prediction for the placement changes. Now see, this is what I wanted to say. Say for example, I am having certain data set. Then on that independent variable is to be plot on x-axis. See, independent variables, and dependent on y variable, y-axis. That is what we give the equation y equals to mx plus c. See over here, y equals to b1x plus b0. Now in this case, if you check out properly, these points, these are the points plotted. See, they represent, if you check it out, they represent a straight line, a linear line. It may happen that the plot may be something non-linear also. We'll come to that point, non-linear, in the next part. But the first and foremost thing what we are supposed to discuss over here is linear. So when I plot the elements onto the graph, I should see some linearity in this. Then and only then I should use this method. See, repeating my point again. So before predicting anything, the first and foremost thing what you need to do is you need to plot your data set onto the graph. Now graph means I'm talking in computer. You can represent it in the form of graph. And based on that graph, you can decide whether linear regression can be applied or not. So whether you can get a straight line or not. So the question arises, if I can get a straight line over here likewise, see in this example, the straight line you are getting because the points are nearby to that. See, these are the points near to this particular straight line. So you can predict the nearby values. See, this cannot be applied. If I give a real-time example, this linear regression cannot be applied onto a stock exchange in the equity market. You cannot predict any of the, say for example, if I take an example of any of the stock, like let's say if I take an example of Reliance Industries, then Reliance Industries price every day with respect to time is not linear. So at that time, I cannot predict the value because it is not linear. So first and foremost thing, I should have the data, and based on that, I can plot it. And based on that, I should find out whether the prediction is possible or not. If it is giving you a linear line like this, then you can say yes, for sure, you can go for the linear regression. Is it clear, everyone? Fine. So the first and foremost thing, you should have the data. See, if I give you a real-time example, as we are online, I can give you a real-time example. What I give you the example for the equity market. Say, for example, if I show you the price of the Reliance Industries, a graph plotting of Reliance Industries. a chart. See the technical chart over here. See, this is the chart for today. Oh, sorry, this is the chart of last 1 year. Last 1 year, these are the points. See, these are the prices on that particular day. If you can see, but over here, if you can plot, see, you cannot get a straight line. See, if you go for a straight line from this points, then what about this part? This is not predicted accurately, this portion. If you draw a straight line from this to this point over here till this, then this is highly going to be inaccurate prediction. Same way, this is highly going to be an inaccurate prediction. Are you getting this? So first and foremost thing, what you need to decide is you need to find out that after you are having the data set, you plot it onto the graph, and then if it comes out to be linear, then you should go for linear regression, because accuracy is everywhere used. We need to verify. Now, if I move further, then what are these coefficients? See, b1x plus b0. Actually, we have studied the geometry in which y equals, the equation for a straight line was y equals to mx plus c, where m is termed as slope and c is termed as intercept. The same is applied over here. b1 is nothing but slope of the line, and b0 is nothing but intercept. What is intercept for b0? That means the value of y when x is 0. Value of y when x is 0. That is termed as intercept. Value of y when x is 0. Value of y when x is 0. So this is what is intercept. So slope and intercept. This equation is nothing but a straight line equation wherein b1 we would be computing and b0 we will be computing, because we are doing the prediction. So we need to compute these two values, b1 and b2, and we need to give the regression equation so that we can predict. So that is what is the main requirement of our task. So let's move further. So how to define the regression line? See, we are not going into the proof of this equation. We will be I'll directly give you the equation for b1 and b0. I will not give you the solution, how it came, because we are not going to that detail of it. We are simply going to have the equation. Now, linear regression finds the straight line. It is also called as least squares regression line. Least squares regression line, or LSRL. That best represents observation in a bivariate data set. Now, bivariate means two variables, x and y. Bivariate data set. Suppose y is a dependent variable and x is independent variable. The population regression of line is given by y equals to b1x plus b0. Sir, this is already you had discussed. Yes, but now we are discussing mathematically. So this is the equation where x is independent, y is dependent. So where b0 is constant, b1 is regression coefficient, x is value of independent variable, and y is predicted value of the dependent variable. So this is you need to remember. These are the terms. Now, in this equation, we are having x. In this equation, we are having x. We are also having y. But we need to first of all find out b0 and b1. We need to find out b0 and b1, so that based on our, now see, the question arises, sir, we are doing prediction. Then how we will be knowing the value of y? From our data set available. Say for example, I am having the past records. So out of those past records, what I can do is I can compute these two coefficients based on the value of x and y which I am having. Then I can form this equation, and based on that equation, I would be now predicting the new values for y based given on value of x. So b0 is a constant, b1 is a regression coefficient, and x is the independent variable, and y is the predicted value of the dependent variable. So how to define this line? How to define this regression line? Am I going faster? All of you, Am I fast? Is it fine? Okay, okay. Is it not so that you people might have started? Are you all listening to me? I am not getting, because if I don't get response, I am not able to teach you, because I get dissatisfied by my teaching, because I always expect the response from the students. Yes, that's it. That's it. That's what I want. I should go slow. Okay, fine, no issue. I'll be going slow. Okay, thank you, Kevin. You are here. Okay, fine. So let's move further. See, what our main goal in this regression is, in linear regression, our main goal is to define this line. Y equals to b1x plus b0. Now in this line, it is already defined. See, if you see this example in this graph, we were already having the data set existing. Previous data set we were already having, and based on this we came to know that we can predict, because it is showing a line. So we can surely predict. But if there are some scattered points, if you check out, see, these are the scattered, if these are proper points given, but these 3 points are over here, these 2 points are over here, this 1 point over here, so I cannot pass a line, nearby line, to this. So that becomes a problem. So first and foremost thing, that is a prerequisite, is that you should plot the points what you are having. We come to this. I'll show you one example. I'll not plot it, but I'll show you. You need to first of all plot it. And based on the plotting, if you can visualize that it gives you a straight line, then you should go for a linear regression. But if this line, if you didn't got this line, instead of that you get a sinusoidal form, or if you get a S shaped form, or if you get a bell shaped form, then you should not go for this equation. Then you should not go for the linear regression. But as what this is been shown in this example, we can go for the linear regression. I can show you the example of non-linear regression, don't worry. So the linear regression example or equation is given by a straight line, which is y equals to b1x plus b0, where b0 is constant, b1 is termed as regression coefficient. Sir, you already told that b1 is slope. No, but with respect to regression, we'll be terming this to be a regression coefficient. But actually, it is nothing but a slope only. Don't worry, it is a slope only. X is an independent variable and y is the predictive variable, that is dependent variable. So now how to define the regression line? Now for that we need to compute these two things, b1 and b0. The formula for b1 is this. Sir, how it came? We are not going into the detail of it. There is a proof given, but we are not supposed to go into the detail of it. So b1 is given by the equation summation I running from 1 to n, xi minus x bar into yi minus y bar, whole thing divided by summation I running from 1 to n, xi minus x bar whole square. So what is this x bar? First of all, it is the mean value of the data set what we are having. Mean value. What is by y bar? Y bar is the mean value of y. So another, our dependent parameter, and x bar average of our independent parameter, and xi means individual terms of the data set, and b0 is given as y bar minus b1 into x bar. See, this is obvious, we can obtain it from this. We can rearrange for b0. It is given as y minus b1x, but over here we will not be using y. Instead of that we are having y bar minus b1 into x bar, because we need to take the mean values and we cannot take any value. Over here we need to take the mean value. So where xi is the x value for observation I, observation means our data set, our record. Same way yi for observation I, x bar is the mean of x, y bar is the mean of y. So you should be clear about this equation now. See, this is the equation to be remembered. But calculation is very easy. You need to remember this equation, but calculation is very easy. It can be asked into the exam that give the regression equation for the given data set. In the exam, it can be asked that give the regression equation, linear regression equation for the given example. And in that case, you need to compute this particular formula. So you should remember this formula. So mainly our goal is now limited to these two things, 1 and 2. But after that, when we get a regression line, that is what we get this equation. So when we get this regression line, the most important part for us is to verify its accuracy by taking the unseen data. That means by taking the value of x and predicting the value of y. So that becomes our prediction. Actually, this is what is nothing but we are predicting. We will be predicting based on our existing set. So what actually the line represents? The properties of regression line says when the regression parameters are defined, the regression line has following properties. The line minimizes the sum of squared differences between observed values and predicted values. And the regression line passes through the mean of the x values and through the mean of y values. And see, mean of x and y. See over here, we are passing the line from through mean of x and y. See, this is the mean of x and y. We are passing it. This is the line. So that is what we will get the line. The regression constant is equals to y-intercept of the regression line, which I already discussed with you. And regression coefficient b1 is the slope of the regression line. This is also I told you y equals to mx plus c. M is the slope. Same way over here, b1 is the slope and b0 is the intercept. Whereas in that case, c was the intercept. So over here, b0 is the intercept. Let's take one example. Let's solve one example. In the exam, it can be asked. Last year, 5 randomly selected students took a math aptitude test before they began their statistics course. So now what that's shown, that 5 randomly selected students were taken who took maths aptitude test before they began their statistics course. That means before joining the statistics course, they gave their maths aptitude test. And what statistics department has a question? What linear regression equation best predicts statistics performance based on maths aptitude scores? See, they want to predict. Those who what type of score they get in maths. Based on that, they want to predict the score of statistics. They want to predict the statistics subject performance based on maths aptitude scores. How? Say, for example, the student 1 is there who gave the aptitude test score and he secured 95 marks. And he got statistics grade to be 85. Same way, student 2 gave 85, he scored 95. Student 3 who scored 80 scored 70. 70, 65 in statistics. 60, 70 in statistics. Now, what they want to do is, based on this, they want to have regression equation. Means they want to create a regression equations so that they can predict the score of statistics based on the aptitude test score. They have to predict. I'm not saying it would be always an accurate result. It is a prediction. I can say, if I say tomorrow there will be rain, it may not happen due to some other parameters. But if the clouds are gathered together, the cloud formation took place, and tomorrow rain probability is there to fall. See, probability. Prediction is nothing but a probability. It will never say an accurate answer. Yes, that if he scored 70 marks in aptitude test, then he is surely going to score that 60 marks in statistics. No, nearby. But it is not, it will not predict that if he has scored 95 marks in aptitude test, then he is going to score 10 marks. No, it is not going to like that. And if he scores 10 marks, then our model is wrong. Then surely our model is invalid. So always remember that part. Is it fine? So this is the question. Now we want to decide, we want to give the linear regression equation. So your first point should be, you should plot these points on the graph. Sir, in exam, are we going to get the graph paper? No, don't worry. In exam, they will mention what type of regression equation you want. And generally, they will always ask for linear regression. They won't be giving any other regression. Fine. So this is the data set given. Now I want to create a linear regression equation. We have already learned the steps. We need to get these two values. Simply, we need to compute B1 and B0. Then our equation is ready. So how to compute this? This is xi, this is yi. These are our equations. Xi minus x bar. What is x bar? What is x bar? Mean value of x. What is y bar? Mean value of y, which I will not show you. So this is the data set which we are having. So what I've done is I've computed the values. This is the sum and the mean for xi, that is aptitude test. Maths aptitude test is 78, and yi, whose mean value is 77. That is the mean value for the statistics grade is 77. Now what is next step? We need to compute xi minus x bar. See, we need to provide the summation of the product of these two terms. So xi minus x bar, xi minus x bar. So 95 minus 78, 85 minus 78, 80 minus 78, 70 minus 78, 60 minus 78. Is it fine? So this is what is the scenario. See, we have computed xi minus x, if you can see. Now similarly, we need to compute yi minus y. See, yi minus y. So yi means 85 minus 77, 95 minus 77, 70 minus 77, 65 minus 77, 70 minus 77. So all these values we got. Next step, to compute the square of this, or you can say the product of this, whatever is convenient to you, because we need to have the product of these two terms, the product of these two terms and the square of this term, that means square of this term. So first of all, I computed the square of this term. So 17 square, 7 square, 2 square, minus 8 square, minus 18 square. And as per this formula, we want the summation of this. Summation. So I had taken the summation of this. Now I need to have the product of these two. So 17 into 8, 7 into 18, 2 into minus 7, minus 8 into minus 12, minus 18 into minus 7. And again, I need to have the sum of this. So I need to have the sum of all these values, which comes out to be 470. See, you got B1 now. Everything is ready for you now. The summation of this two, summation of this means summation of this, that means this value, divide by summation of this value, that is xi minus x bar whole square, that is this value. So this divide by this. So you got B1 now. Sir, is this very simple? Yes, it is very simple. So you got B1 now. So now what about B0? Now what about B0? Y bar, that is y bar is 77 minus B1 you got into x bar, that is 78, which comes out to be this value. So your sum is solved. You got the regression equation. Y equals to B1x plus B0. So B1x, B1 0.644x plus B0 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.768. 26.7 So this is what you got. Yes, your sum is over. But now my question arises, this was the data set given to us. Xi value, yi value was given to us. That is aptitude. See, the question was 5 randomly selected students took a math aptitude test. So X was there with us before they began their statistics course. And statistics department has a question: what linear regression equation best predicts the statistics performance? What should be the performance of statistics based on maths aptitude score? So they took the data set for 5 students who had applied for aptitude test score, who got their aptitude test score, and who got their statistics grade. Now, based on this 5 students, we want to predict some new data. Say for example, if a student scores marks 75, if student scores marks 75 in aptitude test, then what can be his statistics grade? See, what can be means predicting what score for statistics we can predict for 75 marks. See, 60, 70, 80, 85, 95. For 75, what we can predict? See, it's not like this way. It should be we are talking of 75, between 70 and 80. If a person scores 75, then what can be his answer? It's very simple. Put the value 75 in this equation. So let's try to compute. See, I have not computed it. I will show you in the calculator. For 0.644 into 75 plus 26.768. So he may score. See, we have predicted the values. He may score 75.068. He may score, if I take an integer value, he may score 75 in statistics, but may not. But he may not. We are not sure. We are simply predicting. So, as per the grades given previously, it is in front of us. Yes. As per the grades given like this, if a student scores 70, then he gets 65. In same way, we had predicted if a student scores 75, he may get 75. So he should be nearby 75. But if he scores 10, then it is not the accurate result. Our prediction was 75, but he scored actually 10. So our regression equation do not fits the data. So the accuracy is reducing in this case. Are you all clear with this? I hope you are clear. I'm waiting for a reply. Is it fine? Are you clear with the linear regression? The question may be, sir, you have not plotted anywhere the points onto the graph. Yes, over here I didn't do that because I was knowing that it is an example of linear regression. So then what we should do in exam? In exam they will be mentioning. So don't worry about that. So whatever in the exam, if they ask you for the linear regression, then you are not supposed to plot the points onto the graph. And if you want to plot it on the graph roughly, that also you can do it. Is it fine? Are you all clear with the method? There are 3 methods to be discussed. One is linear. Second is related to linear, that is non-linear regression. So the next what we will be discussing is non-linear. Is it fine, all of you? Are you all clear with this example? In the exam, they can ask the question in the same way. They can ask, what linear regression equation best predicts the statistics performance based on math aptitude scores? And the data set is given. Based on it, you need to compute this formula, two formulas. For that, we computed xi minus x bar, yi minus y bar, then xi minus x bar whole square and its summation, then xi minus x bar into yi minus y bar and its summation. We plotted the values in this formula and we got this value. And for b0, we require b1, so we got this value. And the regression equation is of the form this. Is everybody fine with this? All of you? Then I can move further. Is it fine, everyone? Okay. Okay. So want to stop or want to continue? Want to continue or want to stop? Yes, one student has told me what is to be done. Okay, let's do one thing. Let's stop at this method today. Fine. We'll be discussing the two methods later on. Okay, okay, fine, no issue. So we'll be discussing the two methods, the rest two methods into our next lecture. Okay, fine. So that's it for today. Thank you all of you. Please put down your roll numbers. No, Devans, it is not like that. B1 is not supposed to be between 0 and 1. It can be anything.